sun. 100 years later, Kepler determined the planetary orbit around the sun wasn't in round circles, but in ellipses. And even today, we're still learning about the universe, but boy, we know a lot more than we ever did before. Here to prove that perhaps once again we are wrong about the universe, senior science writer for Time magazine, Michael Lemonick, and the new book is Echo of the Big Bang, and I cannot wait to sink my teeth into it. Michael, welcome.
Thanks.
It's good to have you. When you write about science for Time magazine, you write about science news.
Right. So what happened this week?
So this is kind of your passion away from the magazine.
Yeah, I mean, every so often there's big news about the universe, but not every week. So when I get to write a book, that's what I concentrate on.
The Big Bang isn't exactly big news, breaking news.
No, but there is breaking news on it every so often.
Well, let's talk about it, because there's a new probe, the Wilkinson Microwave Anisotropy Probe.
Right.
This is something that they sent out into space?
Sent out into space. It was launched in the summer of 2001, and it first reported back with data about a year ago.
Now, what is an anisotropy probe? What does that mean?
It's looking at the radiation left over from the Big Bang.
Leftover radiation from the Big Bang.
Right, and what it's looking for in particular is hot and cold spots in that radiation. If the radiation were isotropic, that would mean
even everywhere.
Completely even everywhere. They are looking for anisotropies, which mean departures from evenness.
Now, what does that tell us? First of all, the Big Bang was the presumptive beginning of the universe, when all matter was just exploded forth, and you could still hear the echoes of the Big Bang, in effect.
Right, or see them in the form of these microwaves.
Right.
And the idea is that it was a ball of matter, a very hot, dense ball of matter, and was shining with the electromagnetic radiation, but some areas were a little denser than others. And so the areas that were a little denser back then shone a little bit brighter. And we're looking for those spots of shining.
How old is that stuff we're looking at?
The stuff we're actually looking at, well, let me go at it the other way, because I don't do subtraction on demand very well.
Okay.
What this satellite has determined is that the universe is almost precisely 13.7 billion years old.
We know exactly 13.7 billion?
Yeah, and that's one of the breaking pieces of news.
And how did they figure that out?
They figured it out by looking at the pattern of hot and cold spots and putting that together with what they know of the physics that was going on then, and they can actually calculate how fast the thing was expanding, how long it had been expanding when this light
Truly amazing.
Yep.
And based on the variations in energy in the echoes of the Big Bang.
Right.
Truly amazing. Now, you say in the book that the universe can be explained with 5 numbers. And we've talked about two of those, the age numbers, right? Well,
right.
Describe the first 2.
Well, before we do this, it's a little bit of a gimmick to say 5 numbers.
I like it. It's a good gimmick.
Well, it's a good gimmick, but I can never remember which 5 it is. And I'll probably end up telling you 7.
Okay, 7 will be fine. But I'll take 7.
As you say, 2 of the numbers have to do with the age.
Yeah.
Or, well, 3 actually have to do with time. 13.7 billion years ago, it started.
Amazing.
About 380 million years after that, the light actually broke free and started shining through the universe.
Where was it before then? The gravity was holding it?
It wasn't the gravity. It was that the material was so dense that light couldn't travel any distance. So
it was too foggy.
It was too foggy, right. And so it was a very bright fog. It would have blinded you. But in any direction you look, there would be this bright fog of light. And then at about 380 million years, it broke free and began to shine through the empty universe.
Took a long time, really.
Right.
What were they doing before then?
Well, there were no stars.
There were no stars.
The matter hadn't clumped together tightly enough to form stars.
What happened before the Big Bang? Do we have any idea?
We don't even know if it's a meaningful question, because according to modern physics, time itself started with the Big Bang. So talking about it can't be before if there was no time.
There's nothing to say at all.
But that may give way to a better knowledge once our ideas about physics get a little bit more sophisticated.
All of this confirms what Einstein theorized almost a century ago, right?
Right. Well, he didn't theorize the Big Bang itself. That's kind of interesting.
That's newer.
He came within a hair of predicting the expanding universe, which is the evidence for the Big Bang, and then he said, "No, I don't believe it."
He didn't believe it.
It didn't. Right. And so he gave up on it.
Really?
So he would actually have had another Nobel Prize probably if he'd stuck with this.
Well, he's not alone. If the great Sir Fred Hoyle denied the possibility of the universe be expanding in the face of all evidence until practically the day he died.
Oh, yeah, yeah. He
Yeah.
never, in fact, he's the one who gave the name to the Big Bang, and he meant it as a put-down.
It's a joke. It couldn't happen.
That's right. It's what, the Big Bang. What, are you kidding me?
But nobody could, the experimental results kept pointing to it, and nobody could explain it away.
Right, right. And in fact, it's this radiation, this echo of the Big Bang that proved that it had happened.
Yeah.
Because that was predicted, and then they went out and found it.
So we got the 3 age numbers.
Right.
What are some more of the 5 numbers that explain the universe?
Well, some of the more of the 5 or 7 numbers or whatever have to do with what the universe is made of. It turns out that about 4% of all that there is what we think of as the whole thing. That is, all of the atoms that make up you and me and the planet,
Right.
and the sun and the stars and the galaxy, everything we can see, everything we've ever seen, that adds up to only 4% of what's out there.
And what's the rest?
Well, another 22%
Yeah.
is what's known as dark matter.
Oh, dark matter.
Which is some form of matter that we can see the gravity that it exerts on the visible
We
galaxies.
can't see it.
We can't see it. We think it's probably some kind of subatomic particle that hasn't yet been detected,
Right.
but we're not positive. So that's 22%.
And what's the other 74%?
Oh, I don't know how you do that. I'm very bad
I
with that.
spent the whole 5 seconds thinking about it.
The other 74% is something that we now call dark energy.
We just recently, last year, I think they just proved it, right?
That's right. And dark energy is some kind of mysterious energy that takes the form of a kind of an anti-gravity force that is making the expanding universe expand even faster. So instead of slowing down, as you might expect, it's actually flying apart even faster.
I love this stuff. The WMAP, the Wilkinson Microwave Anisotropy Probe, is still out there. We're learning more stuff from it still?
We will be, yeah. It's now been a year. This book is based on the first 6 months of data, which is enough to answer these questions.
Right.
But it's now been operating for an extra year, and they're getting the numbers more precise, and it'll stay up there for another couple of years.
It's just amazing. The Echo of the Big Bang is the book. Michael Lemonick is the author, and fascinating stuff, too. For more information about WMAP and a link to buy Michael's book, we've got it at our website, thescreensavers.com. Stick around, more Screensavers after the break. I love this stuff.